Hi, in this video, I'm going to show you an architecture for the real-time fraud detection, which is very important next to the performance of the models, also to have the real-time detection of the model, because in the payments transactions where we have uh, big data, where we have thousand and thousand transactions at the same time. It's important to have the correct infrastructure in the production that would detect real time whether it's a fraud or legitimate transaction in order to avoid reputational damage of the institution or to avoid the fines in the future because of the fraudulent transactions. So this is educational purpose for the educational purpose. So there's not in the real life example. So we're creating the portfolio and the project, and here I'm gonna show you how it would look like in the your personal portfolio. So let's start from the architecture. So diagram of the architecture, as you see, that it's composed of five processes, five stages. Then the first stage we are getting from the Kaggle original data set. So this original data set is the payment transactions, and among which we have several features and target variable. So target variable is sometimes fraud, sometimes legitimate. So of course it's anonymized. So the researchers did analyze this. But now the topic is not about model itself, but rather the architecture, how in the overall picture, in the big picture, how it's gonna fit. So that's why, for the sake of simplicity, we're just going to quickly train our Python. And the training, I'm gonna show you what's the training, and now it's training in the background. So the trained, we are split into 80 to 20 and saving the model in the pickle file. Then we're simulating the real-time random transactions on the separate file, separate script, and this is passing to our analysis. In between the simulation and the analysis, we have the processing, right? So this is important part. You need to have Docker installed and Kafka installed in your computer, because it is actually the part where we are using the power of Kafka, and of course we are storing it in the Docker, power of the Kafka to uh, par to have the parallel processing um, of the processes, right? So you might have thousand and thousand um, transaction at the same time, and it's important to have the correct infrastructure. And Kafka is made for working with the streaming data and big data. So this is the part we are taking care of the streaming data, and here we are evaluating the model and giving the label to the model. Last part is also the for the decision makers. If the agent should stop the block an account because of the suspicious fraud transaction, uh, agent will see on the front end. I mean, when I say agent, I mean like agent who's taking care of the transactions, right? So for the sake of simplicity, now we have the fraud data CSV as a database, but normally it shouldn't be here, but should be the proper database in cloud or in the server. So let's go to the details of the code. And by the way, it's all stored in the GitHub, so you can actually read about the project. You can actually download and clone it and simulate it in your own local machine, right? So end result is like this. So we are having the continuous streaming data, and now you don't have any fraud detected, but I'm gonna close it right now and rerun again. And we can now have this Visual Studio Code in which we have scripts, right? Let's close this. All right, we have 1 to 4 Python files. In this, we are doing the training. We are taking logistic regression, random forest, and XGB classifier. We are doing the cross-validation and grid search in order to optimize our models. And in this small example, very quickly, we are saving the model, which is performing the best in our models here. The fraud model PQL, pickle. And once we have the model already, we can run parallelly. It's important here to use the Kafka because here you can also train without Kafka. So we're just training the model, right? But here it's important to train to have the Kafka already running, and you need to also Docker running behind. So here you're gonna simulate the synthetic data by using the variables that we already had in original data and randomly generating every second, actually every 5 seconds, the new data. And at the same time, we have other consumer, which is actually evaluating the data and giving the label based on the model, right? So here we have the predict. So this is actually the model predict. And by using the features of the model, right, we are classifying if it's one, it's fraud, otherwise it's legit. And everything is going to be shown on the dashboard. It's the Streamlit dashboard. And we have also the configurations of the Docker file, right? And fraud data looks like this. So we have variables, prediction, timestamp, user ID, and time. And last but not least, we have requirements if in case if you want to replicate this project in your Git and clone it, you need to run everything as I have. Otherwise, it might not work on your computer. So we just click on the create start project. It's actually automating what would you do manually on the Windows, the clicks that you are clicking on the several running that click story. The Python that you would run in your terminal, this automates that terminal runs. So now we will have our dashboard open. As you see, we already have the fraud monitor. So we already have like it's already started. So it has refreshed from 0. We have right now 5, 10, and so on. It's gonna increase. And this is actually what is running in behind. So this is the where we are generating real-time data, and this is what we are generating, evaluating at the and in the same time. This is sending, and this one is evaluating our data. So yeah, so this is the project is overall ready. So this is the this project is the local version of what would be the production, because in production, of course, you need to have the proper environment to run it, proper database, and you might use the power of the cloud technology. And of course, the scalability is going to be higher. So, but this project is made to show what it would be in the model part, like this as a minimal viable product, how it would look like if we would scale it. Thank you for your attention and see you